Hello everyone, welcome to SANGAM tutorials. We speak Gubbi online classes for NCERT 10th standard and CBSE 10th standard for mathematics and science. So in the last session of science, we had discussed regarding the Snell's law for refraction of light. So it was a very important topic. So refraction of light through a glass slab, which is very important. So the emergent ray and the refracted ray is slightly, we can see a lateral shift in that. So those points are very important in that. So I will repeat. So in case of the light ray traveling through a glass slab, the emergent ray where it goes out of the glass slab, and the lateral shift, that is the light ray after refraction when compared to the incident light ray, it is shifted sideways. That's called lateral shift. So lateral shift and the emergent ray. So you have to concentrate on those two things. So here the angle of incidence is equal to the angle of emergence, so which is equal and opposite. So that's very important to read the textbook. So whatever there is in the textbook and beyond that I have discussed with you. So that's very important. So they will be asking you for 3 marks in that. So describe the phenomenon taking place when the light passes through a rectangular glass slab. Describe the experiment of refraction of light when it passed through a rectangular glass slab. So this is the question asked in CBSE examinations. So next is very important, the laws of refraction. So first law, the incident ray, the refracted ray and the normal at the interface separating the two media at the point of incidence all lie on the same plane. So this is here, if I had this, you have to write it a number of times until you get a good grip on that. So you should be easily be able to present that in the examination, right? So second law of refraction, that is the sine of angle of incidence to the sine of angle of refraction with respect to any two media and with respect to any colored light is always a constant, and that constant is called as the refractive index, right? So once again, the sine of angle of incidence, the sine of angle of refraction for any two given media and the color of the light which is used is always in a constant, and that constant is called as the refractive index. So refractive index is indicated by the letter, small letter n, right? So usually in your examinations, what type of questions you are going to get? So here, so in the last class regarding refractive index, we have discussed two things. One is relative refractive index or just refractive index. Second one is absolute refractive index. These are the two things we had discussed. So as there should not be any confusion, I am going to repeat that. So now, when you compare the speed of light passing through any medium with the speed of light in vacuum, then the refractive index of that medium is called as the absolute refractive index, right? For example, speed of light in vacuum by speed of light in glass, that's called absolute refractive index of glass. Another example, speed of light in vacuum by speed of light in water is called absolute refractive index of water. Another example, speed of light in vacuum by speed of light in diamond is the absolute refractive index of diamond. Another example, speed of light in vacuum by the speed of light in crown glass is the absolute refractive index of crown glass. I hope you got the entire thing. Let us come to relative refractive index. Speed of light in air, okay, but we will go with another best example. Speed of light in glass by speed of light in water is the relative refractive index of water, which is in the denominator, which is in the second medium, right? Next, the speed of light in diamond by speed of light in water is the relative refractive index of water, which is water is in the denominator. Another example, speed of light in crown glass by speed of light in diamond gives relative refractive index of diamond, because speed of light in diamond is in the denominator, right? Is that clear? So once again, another example I will give you. Speed of light in kerosene by speed of light in ice is the relative refractive index or refractive index of ice, right? But if you take the absolute refractive index in the numerator, you have to consider the speed of light in vacuum only, right? I hope you got it. I hope there are no confusions now. So in this class, keeping all these things in our mind, we are going with the important questions. What type of questions you are going to get in your examinations based on the relative, that is refractive index of a medium, right? So we'll go with some more questions. I have framed some questions here, right? So we'll go with this. For example, water has a relative refractive index of 1.33. Refractive index of water is 1.33. I am not telling you it is absolute refractive index, that is I am telling you the relative refractive index of water is 1.33. What is the meaning of this statement? So the ratio between the speed of light in air to the speed of light in water is 1.33. That is relative refractive index of water. I hope you got the meaning. We will go with another example. Refractive index of diamond is 2.42. What is the meaning of the statement? Refractive index of diamond is 2.42. What is the meaning of the statement? Refractive index of diamond is 2.42 means this is the ratio of speed of light in air to the speed of light in diamond, whose refractive index is 2.42, right? Let us go with another example. Crown glass, refractive index is 1.52. Refractive index of crown glass is 1.52, that is given. So he is going to ask you what is the meaning of this statement. Crown glass has refractive index 1.52 means the speed of light in air, the ratio between the speed of light in air to the speed of light in crown glass is 1.52. That is the thing you have to write. I hope you got it. So now, so here we will go with a very simple problem. Two problems I am going to present. Velocity of light in water is 3/4 times the velocity of light in vacuum. So that comes to absolute refractive index because we are using vacuum here. So velocity of light in water is 3/4 times the velocity of light in vacuum. Find a refractive index of water. This is the question. So these problems I am going to send you today itself through WhatsApp in notes. It will be in the notes. Don't worry, just listen to me and observe how I solve it. Velocity of light in water is 3/4 times the velocity of light in vacuum. So let us guess the speed of light in vacuum. So let the speed of light in vacuum be x. Let the speed of light in vacuum be x. Now, velocity of light in water is 3/4 times the velocity of light in vacuum. So, therefore, velocity or speed, velocity of light in water B 3x by 4 because it is 3/4 times the velocity of light in vacuum. So, let the speed of light in vacuum be x if you guess it. Then the velocity of light is 3/4 the velocity of light in vacuum, that is velocity of light in water B 3/4 into x, that is into x, that becomes 3x by 4. So here velocity of light in vacuum Bx can be taken as c because c is the velocity of light in vacuum which is symbolically represented. So let the velocity of light in water be 3/4 into x, that is 3x by 4, that is to be represented by velocity of water in velocity of light in water. So we will take it as VW, right? So now find the refractive index of water. We have to find the refractive index of water. So refractive index of water, N represents the refractive index and W represents water. So refractive index of water is C by VW. That is refractive index of water is equal to velocity of light in vacuum by velocity of light in water. So NW is equal to C is x by velocity of light in water is, that is 3x by 4. Let us take the reciprocal. So NW is equal to x by 1 into 3x by 4 is taken reciprocal, that is 4 by 3x. X and x cancels. So velocity, that is refractive index of water is 4 by 3. So it is approximately, it is 1.33. So this is how we have to solve it. Right? So these questions will be asked for multiple choice or one mark questions. Okay, let us get into the second problem. Light enters from air to glass. Light enters from air to glass. Okay, so let us take a rectangular glass slab. So this is air and this is glass. So light enters from air to glass obliquely. So if you draw a normal, so it bends towards the normal because it is optically rarer medium and this is optically denser medium. So this is the normal and the light ray is going to bend towards the normal because light ray enters from rarer to denser. Okay. Light enters from air to glass with refractive index 1.50. That is, the refractive index of glass is 1.50. He has given it. Find the speed of light in glass. We have to find the speed of light in glass. If the speed of light in vacuum is, that is 3 into 10 to the power 8 meter per second. So instead of air, he has given it as vacuum. So no problem. The velocity of light in air when compared to the velocity of light in vacuum is, that difference is not a very big one. If you consider that velocity of light in vacuum is 1, then the velocity of light in air is 1.000033 something. Right? So its difference is very small. So therefore you can take air or vacuum, whatever it is. So now, so velocity of light in air is 3 into 10 to the power 8 meter per second. So refractive index of glass is 1.50. You have to find the speed of light in glass. So we are given with C is equal to 3 into 10 to the power 8 meter per second, and refractive index of glass, that is Ng, that is refractive index of glass is 1.50, and you have to find the velocity of light in glass. So that is velocity of light in glass Vg is equal to how much? So very simple formula we can use. So that is N is equal to C by V. So N is nothing but Ng, that is 1.50 in this case, and C is 3 into 10 to the power 8 by Vg. So we have to find out this. So by 1, let us go with cross multiplication. So Vg into 1.50 is equal to 3 into 10 to the power 8. So it is 1.5, you can take it as 1.5 itself. So Vg is equal to 3 into 10 to the power 8 by 1.5. 1.5, 1 times, 2 times. So Vg is equal to 2 into 10 to the power 8 meter per second. So the velocity of light in glass is 2 into 10 to the power 8 meter per second. Okay, so this is the thing. So we are given with an application question here. So now, water has optical, water has refractive index 1.33, glass has refractive index, that is 1.5, and diamond has refractive index 2.4, and alcohol has refractive index as 1.36. So these are the things given to us. So this will be given for 2 marks. Compare the optical density. The question is like this. 4 substances are given to you and their refractive indices are given. So using this, you have to compare the optical density. Find medium with the lowest optical density. So here, lowest optical density is for diamond, because when you compare all the 4, 1.33, 1.5, 2.4 and 1.36, diamond has the highest refractive index. So it is the highest refractive index. This is the highest refractive index. So a substance having the highest refractive index will have the lowest, that is optical density. highest refractive index. So he has asked you the question, compare the optical density. So here this has the highest refractive index, therefore it is having the highest optical density. This is the first place, goes to diamond. And the last one, which is 1.36 here, 1.5 and is 1.33. So this is the lowest. So lowest refractive index. So lowest refractive index, that is lowest refractive index. This has, water has the lowest refractive index, so therefore its optical density is very less. So highest refractive index has more optical density and the lowest refractive index has the lowest optical density. So lowest optical density means speed is high. Speed is high. Highest refractive index is speed is low in this. So this is the relation we have to understand and remember. Very simple. I am going to repeat. So 4 substances are given to you and their optic, that is refractive indices are given. So now he has asked you to find out the substance having the highest optical density and the lowest optical density. So compare the values. So which particular refractive index is the highest? So that becomes the highest refractive index. So 2.4 is for diamond. So diamond has the highest refractive index and water is 1.33, that is having the lowest refractive index. So what is the difference between lowest refractive index and highest refractive index? So here a particular substance having the highest refractive index will have lesser speed of light. In the sense the light travels at the lowest speed in that particular substance. And the substance having the lowest refractive index, in that substance the speed of light will be very, very high. So this is you have to remember. So highest refractive index, lower the speed. Lower the refractive index, higher the speed. So refractive indices and the speed of light are always inversely proportional. So if one rises, another decreases. So highest refractive index, the light traveling through those substances, speed will be less. Lowest refractive index, the speed of the light will be more in those substances. You have to remember the criteria. So next, we'll go with another question, another one. So I am having 4 media here. So medium and refractive index. Okay. So let us take it as medium A, B, C and D. So it is 1.33. So it is 1.52, 1.44 and 1.65. So this is the refractive indices. So this is medium A having refractive index 1.33, medium B 1.52 refractive index, medium C 1.44 and medium D 1.65. So these are the refractive indices. So they will give a table like this and they will ask you to find out the highest speed. They will ask you to find out the highest speed of light in a particular medium. So here, in which particular medium the speed of the light will be the highest. So which medium has the highest speed? So the medium having the lowest refractive index. So which is the lowest refractive index? So that is for 1.33. So here the speed will be the highest. Next, D, that is 1.65. This has the highest refractive index. So therefore the speed will be very less in this. Lowest speed. So lowest speed is recorded in those substances having the highest refractive index, and the highest speed is recorded in those substances. Highest speed of light is recorded in those substances having the lowest refractive index. Once again, I will confirm this. More the refractive index of a medium, less the speed of light through that medium. Lower the refractive index of the medium, higher the speed of the light in that medium. If you remember this, you can answer n number of questions on this particular topic, right? Okay. So I will give you a homework now. So I have 3 substances with me. One is kerosene. That's one of the substance. Another is turpentine. Another one is what? I have 3 substances, right? So refractive index of kerosene is 1.44. and turpentine is 1.47 and water is 1.33. So these are the things given. So now the question is, which particular substance has the highest refractive index and lowest refractive index? You have to answer this. Find out highest refractive index and lowest refractive index. Right? And second question is, in which particular medium the speed of light is highest and lowest? You have to identify. Right? So this will be asked for in your exams for, that is 2 marks will be asked. Right? So I hope this completes the concept of refractive index. Please remember all the concepts, because in the next class I will be getting into lenses, which is very other important part of the chapter. So after learning lenses, we will get into numericals, and then we will go with the power of the lens and numericals, and we are going to come to the end of the chapter there. Right. So I hope you enjoyed the entire session. So keep learning, stay home, stay safe.